So please look at the current problem. You're trying to integrate ln x the whole function square. And just to give you a note, I'm talking about ln x the whole thing square, which means it is ln x times ln x. It is not the same as ln of x squared. They are not the same thing, totally different. I'm not talking about this. I'm talking about the first line. Anyway, surprisingly, I claim that the integration by parts formula works, and the good thing about this case is we don't have the choice of u. I think we just have to use the u be the ln x square, and the remaining term be dv. So u is the whole thing, ln x the whole thing square, and dv is dx. And v is easy to find because it's integration here for the dx. You are integrating 1, so v is x. And what is du? Du is gonna be the derivative of ln x square, the whole thing square. And please recall the chain rule application. The derivative is going to be 2 times ln x. I'm using a chain rule now by letting u be ln x. And you have to multiply this one by the derivative of ln x, right, which is 1 over x. And it means I can copy it here, which is 2 ln x times 1 over x. That's the du term, and which is fairly complicated. At this stage, it may not be easy to see why our choice works, but let's try it out now. So you see, the fact is that you have to write down all the terms carefully, and we have to check it out. And u is ln x, the whole thing square, times v is x, and minus the integral of v is x, and u is complicated, is 2 times ln x times 1 over x dx. So you see, there are quite a few terms inside the second integral. So let's see why it is easier than the original problem. Because you see the x term can be cancelled, right? The top and bottom, which means for the second integral, we are actually left with something easier. So for the second integral, we are actually left with the 2 can be out. We are actually left with just the function ln x inside. I hope you can try to compare what you have. At the beginning, I asked you to integrate ln x squared, and after the use of integration by parts one time, we are reduced to an integral on the second term of the right-hand side, which is not that easy to do, but at least it is easier than the original problem, right? Because at least it looks like you're reducing the power of the ln x by 1. And if you recall what we did in a previous exercise, we actually found the answer to the integral of the second term, which is x times ln x minus x, and the plus c we can put at the end. So this one is the integral of ln x, and this one you have to use integration by parts one time. So it means altogether in the whole problem here, we are doing integration by parts 2 times, right? Because for this term to use integration by part is the second time already. So this problem, please look at the procedure. It looks like for ln x to the power 2, we need to do the integration by part 2 times to reduce the power of ln x. Every time we do the by part 1 time, you can reduce the power once. So I make the following notes here. So please look at the note in the black color. I claim that we can always integrate all the functions which look like the function ln x to the power n. And the way to do it is to use the integration by parts formula n times, depending on the value of n. For example, in the current problem we just did, the n is 2. That's why we needed 2 times of integration by parts. If the n is bigger, let's say n is 5, then you have to use 5 times of integration by part to get to the final answer. And every time you do the integration by part once, the power of n reduced by 1, and at the end, you should be able to solve it. And that's the note I can make for such type of integral, and we can look at more problems. So please look at the current problem, which is the integral of x squared times sine of 2x. I claim the integration by part can work, but we have to be very careful about that. And I think in the previous video, we have done an integral for x times cosine x, and we did it by part formula by using u be the x term and dv be the remaining term. So we'll use that hint to carry on our current problem. So u is x squared, dv is sine of 2x dx, and du is the derivative of x squared, which is 2x. And for dv to v, it's gonna be the integral of sine of 2x, right? And sine becomes minus cosine. But because of the 2 here, so we have to divide the whole thing by 2. And that's usually how to work out an integral like this. the factor 2 attached to the variable x is a division factor when we do the integration. And anyway, let's write down the next step. So the term that matters is the second term here, which is the integral of v times du. And let's write down all the steps together. So v is minus cosine of 2x over 2, and v is minus cosine 2x over 2 inside the integral, and du is 2 times x times dx, right? And let's try to simplify what you have in the integral. 2 and 2 is cancelled, and I think the minus can be moved to the front, right? And it means that I can write the next step down, which is minus x squared times cosine of 2x over 2 plus the integral of x times cosine of 2x. And this one is not a very easy integral, but let's look at how you change the problem by applying the integration by parts. You see at the beginning, you are having a function which is x squared times sine function, right? After the integration by parts one time, we are reduced to an integral which is slightly easier, which is x times cosine 2x. It is easier because the power of x, you see, is decreased by 1. So you can imagine what's happening if you are doing the integration by part the second time now. If you do it the second time, we expect that probably the power x will be decreased by the power of the x term will be decreased by 1 again. So it means the x is gone, and we can change the cosine back to sine, right? And that's our expectation. So I'm just making a guess here, but let's see whether my guess is correct. So it means I let u be x and dv be the remaining term, which is cosine of 2x dx. And du is easy because x derivative is 1 times dx, and dv to v is an integral. Integration of cosine of x, it becomes a sine of 2x. You have to divide it by 2. And let's try to write down this integral in the green color. So it's uv minus the integral of v and du. U times v is x times sine of 2x over 2 minus the integral of v is sine of 2x over 2. Du is dx, right? And I think you're able to integrate this, right? And it is the same as our expectation. The 1 over 2 as the constant attached here doesn't matter much. We can pull it out. But the key fact is that we are successfully reducing the power of the x term. We decrease the power here by 1, so the x is gone. When the x is gone, we are left with just the function sine of 2x to integrate on the last line here, and which is easy. So let me write down the answer on the next line. So it is minus x squared cosine of 2x over 2 plus, open brackets, let me copy this inside there. So it's x times sine of 2x over 2 is minus 1 over 2. I pull it out, the 1 over 2 here. You have to integrate sine of 2x. And let's try to do this problem now. So let me write down all the terms quickly. So we are having this. The first two terms are done. But this term now is the integral of sine of 2x, which is minus cosine of 2x over 2, right? And we have to add a c at the end, so it is essentially the final answer to this problem. So let me make a note here. If you are encountering an integral which is the product of two functions, which is like a x to the power something term times cosine or sine or e term, so n must be a positive integer like 1, 3, 4, etc. And we can always solve it by integration by parts n times, depending on the value of n, which is the power of x. And every time we do the integration by parts, we can reduce the power of x by 1. So that's the key here. And we have to let u be the x to the power n term and dv be the remaining term. So if you keep doing that n times, you're able to get to the final answer. And for all these type of integrals. And that's the end of this video.